Do you know what makes a rhombus a rhombus? And do you know how to find its area? Well, it seems a few years ago that almost a third of A-level students didn't know the answer to those questions and therefore scored 0 marks on this question. The examiners noted that the mean mark for this question was only 1.9 out of 6. They said that surprisingly, many candidates were unable to use or remember the basic geometry of a rhombus, and over 30% did not manage to make any progress at all. Oh dear, let's make sure it doesn't happen to you this summer. Figure 3 shows a sketch of a parallelogram PQRS. So we're told it's a parallelogram, and we are given that PQ is this vector, Q to R is this vector, and we're asked to show that the parallelogram is actually a rhombus. So first of all, what makes a parallelogram a parallelogram? Well, it's a 4-sided shape, a quadrilateral, with 2 pairs of parallel sides. So we're allowed to assume that P to Q and R to S are parallel, and P to S is parallel to Q to R. But what makes a rhombus a rhombus? Well, a rhombus is a special type of parallelogram. A rhombus is a parallelogram where all of the sides are actually the same length as one another. So, how can we show this? Well, we can work out what the length of P to Q is, because that will be the same as S to R because it's a parallelogram. And separately, we can work out what the length of Q to R is. And we can show that those two are the same length. So, we're given in the question P to Q, that's this vector here. So we can easily work out its length, its magnitude, its modulus, using the 3D version of Pythagoras. It works just like in 2D, except we square all 3 components and then take the square root of that. If you do the number crunching, you get root 29. We can do exactly the same kind of thing with Q to R, squaring the components of the vector, adding them all up, and then taking the square root. And we get the same thing. That gets you the first mark, but to get the second mark, you must write down a clear conclusion. So what do we write down? We say that the length of P to Q is the same as the length of Q to R. They're both root 29. So that means that PQRS is a rhombus. So don't forget to write down that clear conclusion to score all the marks. Part B. This asks us to find the exact area of the rhombus. How can we find the exact area of the rhombus? If I put in these diagonal lines here, and we draw a rectangle around the rhombus, such that the corners of the rhombus touch the rectangle, hopefully you can see that each section that we have here is half of this enclosing rectangle. So this triangular section is half of this rectangle. And it's the same for all 4 sections, right? So therefore, the area of the rhombus actually is half of the area of the enclosing rectangle. How do we find the area of the rectangle? Well, we do base times perpendicular height. Now, you can see that the base here corresponds to the length of this diagonal of the rhombus. And then the perpendicular height here, again, corresponds to the other diagonal. So what we need to do is to find the length of each of the diagonals, multiply them together, because that will give us the area of the enclosing rectangle as a whole. But then we need to half it, because the rhombus has half the area of that enclosing rectangle. So that's what I've written here. The area that we need is half of the length, the magnitude of this vector that takes us from P to R, multiplied by the length of the magnitude, the length of this vector that takes us from Q to S. So let's see if we can work out what the length of P to R is and what the length is Q to S is. Then we can use this formula to work out the exact area of the rhombus. Let's start with P to R. How can we go on a journey from P to R? Using the journeys that we've been given in the question. So we've been given in the question P to Q here and Q to R. Well, if I want to start at P and end at R, well, I don't know how to get there directly, but I can go from P to Q and then from Q to R. So that's what I've written down here, P to Q plus Q to R. P to Q, that's our vector here. I've just written it in column form, 2, 3, minus 4. And Q to R, be careful with this one. It's 5i, but 0j, so we've got to put a 0 in there, minus 2k, so minus 2 at the end. Don't forget the 0 here. We just add these vectors component to component. So we add the 2 and the 5 to get 7. 3 plus 0 gets us 3. Minus 4 plus minus 2 is minus 6. So that's the vector P to R, but I need to use the size of that vector, the length of that vector, in my area formula. So we're going to have to find the magnitude of P to R. So again, our 3D Pythagorean formula comes in handy. So we take each of these components, we square them, we add all of those up, and then we take the square root of all of that. And if you do that, we get the square root of 94. We also need to find q to s. So how can I find the vector q to s? So we're starting at q and we need to end at s. I don't know how to get there directly, but maybe I can use these vectors we were given in the question to help me. So, well, let's think we could go from q to r and then from r to s. So that's what I've written down here. We know the vector q to r, we know that one, so that's fine. But what about r to s? Well, r to s going in the same direction, and in fact it's the same length as q to p. But I don't know q to p. But I do know that q to p is the negative version of p to q. It's the same vector, just going in the opposite direction. So we can just swap these letters over and change the sign from plus to minus. So q to r, we know that vector, that's in the question here, just written that in column form. And p to q, we also know that vector, again it's in the question here. Again, I've written that in column form. So we just subtract these two vectors, just watch out for the -2 minus -4 there to give us +2 here. And if we get that far, we get our first 2 marks of part B. So we need to find the length of this vector q to s, the modulus, the magnitude. We use 3D Pythagoras like so, and we get the square root of 22. So let's go back to that area formula and put in what we know. We know that p to r was the square root of 94, so that can go in there. Q to s was the square root of 22, that can go in there. If you combine together these two square roots, we can do the square root of 94 times 22, well that's this number, and actually you can use your calculator to verify that this becomes this, and the 2's will cancel here to leave us with the answer. That's the exact area. Remember that word exact means no decimals allowed, so we want to leave our answer just in this surd form, this square root form.